Let's finalize our Jiralib and continue forward. Hello everyone, this is Ali Reza. Welcome to the Mentor Code Lab. Between the previous episode and this episode, I sit down and wrote an example of how you would use the block entity properties. Because right now we had seen Turti utilizing the block properties, but we didn't have an example on how we should use the block entity properties. Now, as you see, this is a block entity that is extending my own no screen updatable BE. And as you see, I added a properties to this. And then I said that, you know what? Okay, I want a tick rate of 0 and tick logic. And then forget about this one and this one. And then came down and thought to myself that, okay, if I have a tick logic, I should be able to tick it from here. Now, I'm assigning it to the properties. So naturally, it would make sense if I get it back and then call the tick method on it. That was the first iteration. Now, going back to the properties, we didn't have any getter for any of these. The reason was that the BE properties was an internal class. And this is why I really hate internal classes, because they mess up the base concepts of object-oriented programming. If I have a private field nowhere outside of this class itself, I should be able to get access to it. But when this class becomes internal, then we have access to it, at least on the top level class. And that is what I really don't like about Java. And as I said many times, I have a background history of C# programming, and I want to stay as close as possible to the base concepts of object-oriented programming. Now that we didn't have access to them, it makes sense if we give ourselves some getters. So I added the get method to get my hand on the block entity and on the tick logic. Then I thought to myself, okay, at any point in time, I may want to get access to the tick rate. Now that I have the access to the tick rate, I may want to get access to the fields. And this is something that makes me confused, and I will come back and talk about it later. However, after my example BE, now that I have the tick logic, now that I have access to fields, now I can set the fields here and tick my tick logic. Okay, so I went down and wrote a tick logic that implements a tick logic for this block entity and the fields of the block entity. And I thought to myself, okay, I would get the block entity and any other information. And actually, if you go back to the previous video, you will see that the signature for iTick was different. And during the iterations, I noticed that, you know what, most of the time I want to check if we are client. To understand if we are client or not, I have access to the block entity, and then I need to get the word out of the block entity, and I need to check if the word is not null, and then check if it is a client, and this would be a hassle because I have to do that chain of commands all the time just to make sure that I'm not on the client side. Although, remember, the tick method is working on the server side and tick client is working on the client side by default. So normally you wouldn't need to do this check. However, it is a nice thing to have it. And I thought to myself, okay, I will send in the word. So the next iteration was to get the block entity and get the word as the signature. And then I noticed that, you know what, I need the word here. So I added the word and I added a method to set the word and a method to get the word. So far, so good. Then I came back to tick logic and I said dot word dot is client. And ignoring this error, we have something here. It says auto closable. Now this made me confused because it shouldn't give me this warning because the word is not the proper type to cause the auto closable warning. It looks like for some reason the IntelliJ is getting confused. So I had to suppress it either here or suppress it in the BE properties. Unfortunately, suppressing it in BE properties does not solve this action here. So I have to do something about it. For example, suppress it for class, method, statement, or completely turn it off. I can turn it off, but I thought to myself, okay, I have access to the word, but what I'm really caring about right now is this. I want to see if the word is client or not. So I added this. We check the word if it's not null and if it's client inside the BE properties and wrapping it up, basically encapsulating the functionality. And then here I can just ask the property to see if it's client or not. And by doing that, I added the flexibility everywhere. Although now that I showed you that, I want to get rid of this warning because I don't understand it and I don't want to see it, So more actions, ignore, there we go, disable inspection. So I won't see that inspection anymore because as much as I know, auto closable in Minecraft will never happen. And honestly, I use Java only when I'm programming for Minecraft. So that being said, now I came face to face with something else. Okay, this is a use case example. We will talk about these comments later, but take a look. In my block entity, I have this register fields. Now here's a question. Do we really need it anymore? Because if we roll back, we see that the only time that is being called is inside the constructor of the properties. And that is exactly where I told you that 30 Vorti's code is making me confused. If we have the list of fields on the properties, and if we can give him a getter, and by being internal, he had access to it directly, then why do we need to send it back to the block entity? Because right now, if you take a look, my signature is now just accepting properties. And by having the properties at any time, I have access to many different things, like the work, the tick rate, the tick logic, the block entity itself, and checking if it's client or not. By having access to the block entity, I have access to all the commands of a block entity, even the position of the block entity. So why would I need to have another copy of the fields here where I'm keeping the properties that contains the same fields? That doesn't make sense. Yeah, you may argue that, hey, you may want to have extra fields on the properties and dissect some of that to be on the block entity itself. But you know what? That's not what is going on. The thing that is happening is that he is instantiating the fields to a new list, and then he is forcing this list to be on the block entity. And here's the fun part. Let's go for our example. The parameters in Java are passed by value as default. So for example, if I pass an integer, this is not a reference type, it's a value type. However, when you are sending an instance of an object, like here, the properties is an instance of an object. When you are doing that, this will be passed as a pointer. What is a pointer? It's an address in the memory. Okay, it's pointing his finger into the memory and says, hey, property is this one, use that one. So even if I call the tick method on an instance of this class here, this one, this property parameter inside here is exactly the same object in memory as this one. So if I change a field on this parameter property that I'm passing it to another method, and inside this method I'm changing a value of the field, if I come back into the tick method of the block entity and down the road I say properties.get.fields.getInt for some value, and what do you want? This as the block entity, and then I assign it to anything or even print it out, you will see that instead of the default 0 that I provided in the constructor, I will get 20 that I set in another class in another method, because this guy in memory is the same as this guy, is the same as this guy. So if I have one instance of properties in the memory that contains fields, and at the construction time, I'm sending the same object in memory back to block entity to be registered in the block entity, it means that I have a copy of the same object pointer in two places, one in the properties, one in the block entity itself. So that makes me confused. Why does he want to do that? So we really don't need to keep our stuff in two places. Now that we don't need to keep our stuff in two places, you notice that it's warning and it's giving me error because I don't override this method. And by not overriding this method, I don't need this method anymore. And now is another part. Where am I using this generic T? Other than this method call and the constructor, nowhere else. So if I'm not using it, why do I have to assign it all the time? Although it's not a big deal and it makes the constructor read much better, but let's face it, most of the time when we are constructing our own examples, we are removing this and we would say mod block entities dot example b, something like that. We have a registering initializer somewhere in our mod that we are making an instance of this block entity being registered, and we keep that as a type. So we are turning that type here and we are using it here. So normally when we call the super, we are not using this. If we are not using that, then that's the only place that I'm using the type now as the generic. So why should I have the generic at all? Drop the generic and here convert it back to unknown. And if I change that, it means that now I have to go back and remove the generic in all of these. So, and as you see, I don't need that. This one will become unknown. This one is not using T, it's just using U because I'm sending the U to be the block payload. Okay, let's use this one as T, T, and T. There we go. And finally, the last one is not using this. Remove that. I don't use that. This is T. And finally, I'm returning back the payload here. Okay, and this one is unknown. Make sure that we fix this. Okay, now that was another thing that I had to fix. So block entity field. Now we don't use B here. Also, one more thing, let's think about it. If I'm not gonna use anything special about no screen updatable BE inside a field or fields or properties, why should I limit myself to my own classes? I mean, what will happen if instead of this I say block entity as the base? And you see that now I have problems on the interfaces, so I have to go back there and make sure that this guy is block entity. That will fix one of these. And then the setter, again, the same deal, block entity. And of course, I have redundant imports now. And that's the whole thing inside my block entity field. Now I have to check my block entity fields to make sure that it is working properly, because yes, it's no more this guy, it's block entity. And as you see, again, the whole thing is working. So if now I roll back to block properties, I can say that T extends block entity. And now I don't need this register field anymore. And honestly, I think that the only thing that is changed is now ITIC logic. Let's take a look at that, because now, yes, it doesn't need to be extending this. It needs to extend block entity. And that would be that. No errors whatsoever. And we are not limiting ourselves to the concept of the no screen updatable BE. The reason is that we are not using update method here. And the main thing is the functionality for the update, late update, and syncing, and the things that we are adding on top of our abstraction layer here. And we are not doing it here. So that's that. Now, this became much cleaner. In my opinion, now I can remove this and these comments, and you see that I don't have this type, but whatever, and I don't need to produce this guy anymore, and the whole thing is still working. Now, why did I go down the road and remove the need to be depending on no screen updatable BE and roll back all the way back to the vanilla block entity? The reason is that I added this project, and as you notice, it sits now before the Jiralib. If I open it, it's just a test environment with an entry for a test, and this will be removed later, but right now it's just there so that I can run the client and get feedback from what I'm coding inside the library. And as you see, it's related to tick logic. Now, let me show you an example of a mockup. Now, this is a mockup that I came up with. And by the way, if you ever wondered what did I use to put this together, there is a part of adopt.com as a free application, and you don't even need to register. Just open source.adopt.com/behavior tree editor, and you can put down behavior trees, although it's not as flexible as I did like it, but I'm marking things as I think has meaning for me. So this is a selector, this is a sequence, this is a condition node, this is a subtree, or at the same time it can be replaced with this section. This is an action node, and these that are not rectangle shaped are decorators. So we have negate, fail, success, repeat number of times, until fail, and until succeed. Also, we have more functions predefined, like wait for some time, error something, and log something. And there is one more that is called done, but I don't see it as a necessity. Let's talk about the mockup itself. This is supposed to be a block entity that is ticking, and this process will work in a single tick. Now, forget about the extra blocks that I put at the right side. We are not working with them right now. And let's focus on the left side. The selector means that each one of these three can return success. The moment one of them returns success, we go out. The very first is this guy. So this is number one. The number one checks if we don't have any progress running, means that our progress is equals to 0. If that's the case, we check the energy. Now, check the energy means that we have another selector. Either we should use energy or we shouldn't use energy. If we should use energy, then we will go back into the next condition and we are checking if we have enough energy. So if this is true and this is true, that is when this selector becomes true, And because the first branch became true, this will become true. Now, for fluid, let's go on the other way. This is false, and immediately as it becomes false, this will become false. Because this is false, then the selector goes to this branch and it says, okay, should use fluid? It's no. It will negate it, so it becomes true. Then it says, okay, I did successfully handle myself. Did you understand the logic now? So this is success, and this is success now. So he will go and check the recipe. Let's say that we have a recipe. By the way, the checked recipe is something like this. And then it will start crafting, for example, by increasing the progress bar. Now, at the same time, it will come back because now it is success and it will go out. The next tick we go in, what will happen? The next tick that we go in, we check if we have no process. Now, this will be failed because process is not zero anymore. So this will become failure immediately. We are not going to dive into this section anymore. And then we go into the second branch. We say, is our progress done? Means that the progress should be equal or greater than the max progress. Well, it's not. Progress is 1. So immediately we fail this branch again and we fall down. It says, is the progress 0? Not true. Is the progress greater or equal to max progress? Not true. Because we are above the 0, we are less than the max. Now it says handle energy. Should we use energy, and do we have enough energy, then reduce the energy? Else we shouldn't use the energy. Either way, one of them will return true. If we don't have enough energy, for example, this will become false, this will become false, and immediately we will bail out, okay? But we suppose that we have enough energy, then we reduce the energy, then we handle the energy, we come out. Now we shouldn't use the fluid, so we fail this guy, but then we will have a branch like this one that we negate it, that would become successful. So the whole node will become success and we handle the fluid. Then we increase the progress, we success, we bail out. We do this as long as we are not greater or equal to the progress done. When we are in that scenario, we come down and we say, hey, please handle the energy, please handle the fluid. Now, if both of them are successful, we reduce the input stack, we put an item in the output stack, we reset the progress, then we are success, then we are success, then we are success, then we finish the tick. As you see, it's normally something like we code, okay? That's the whole concept. But the thing is that I want this library to be free and unrelated to other libraries. Right now, I'm depending on the logger and reference because my test environment will use these two. However, when we are finished, we will not bind ourselves to the logger or the reference. This will be a unique library, independent of any other library at all. So I shouldn't be bothered with something like being updatable because I won't have access to any of these interfaces. Also, I will copy this block entity properties and fields, not the block ones, just the block entities with the needed interfaces or anything else that I need for this to work and put them inside the tick logic. And I won't remove them from Jiralib for time being because right now, I'm getting done with Jiralib. I want to move forward to inventory, then fluid, then energy, then machina, and I want to finally go back to my main mod. But in parallel with my main mod, I want to start working on the tick logic in my free time. And as I go forward, I want to have the same copy of the same files in both places until this library is finished. At that time, Jiralib will depend on the tick logic, and the files in Jiralib that are shared with this one will be deleted from Jiralib. That's a progress and a talk process for you. But because I have to move them inside the other library, that is why I made the decision that, you know what, the iTick logic, the BE, the fields, every one of them should be free from the no screen updatable BE, because honestly, I don't need that. Also, I think that I will now expand on the idea of BE properties and use some things that are being used by block property. I'm not sure. I mean, the same concept, because right now I have updatable and ntick, and I'm not covering the synced ones. And again, the combination of these will be at least 4 more classes sitting here. And I don't like it, you know. However, we will see how things work in the next episodes, because right now I need to go back and finish this library, and for that I need to implement the general block entity that will use the properties, and then I will have a block that will use the properties. I think I will call that GBE or GBlock entity and GBlock, something like that, and we will have to work on those in the next video. However, this video was an update on the changes we had to do, and also taking a look at how we can utilize our properties inside any block entity. Now, as much as I care, this can be a simple block entity and the whole thing will work. Of course, we don't have the tick method yet, we don't have tick client because they are not overrides, but now I can add a tick method and register that tick method. So the thing is that my block properties is dissected from any block entity, and that is how I like it. In the next video, we will come back and start working with the block first and then block entity and utilize the properties that we worked so hard on them. I will remove these examples because honestly I don't want them anymore. If I need to do anything at any time, now I will go back and edit them. By the way, the last thing that I forgot to mention is the last iteration of the iTick logic is now accepting the properties, because in my opinion the properties has access to the block entity, has access to the word, the fields, everything, so we don't need anything else in our tick logic. One more thing, because we move block properties outside of the block class, again we don't have access to any of these fields by default. So I had to sit down and write the getters for the properties, and I used regions for the set ones and a region to put things together and organize them better for the helper methods. That's one thing that we added, bunch of getters that will return this.law, and we will get access to all of these from the instance. And that was this one. Finally, we are ready to sit back and write our main block that will eliminate the concept of having 4 different abstract block classes. If you like these videos, please subscribe to the channel, hit the like button, and turn on that bell so that when I publish a new video, you will get informed. Have fun, everyone. Bye.